So welcome to the session on SLL Drona, which is an early preview version. And this is an open source LabVIEW UI testing tool or framework. So yeah, to start with, we have that I'm privileged to talk about giant cell female on the ISRO scientists. So this is specifically on the Mars orbiter mission. So this was planned and completed in just 15 months with a budget of $70 million. And to just give that a perspective, right? So the cost per kilometer was just 10 cents per kilometer. So the budget was $70 million. The distance from Earth to Mars is around 650 million kilometers, which results in a awesome mileage of just 10 cents per kilometer. And also the other key thing was the mission was planned to have only a lifespan of 6 months, but it actually ended up working perfectly fine for 8 years. And I think this overall mission were like a lot of women scientists that contributed to this, and more specifically Nandini Harinath was the project manager, and Ritu Haridal was the deputy operations director, Maumita Datta was the project manager, and Minal Rohit. So these are all these women scientists greatly helped in achieving this greatly wonderful and proud achievement. And I think this is something that I'm very happy to present and talk about. Yeah. Okay. So next, coming to the team which made the SLL Drona possible. So this was something that was done internally within Solton Technologies, but we made a decision to make it open source. So hi, I'm Karthik. So the original idea was something that I was started up, and then I pulled in Kirti and Sairam, Sandhya, Sudarshan, and Indu, and getting it to something in a state that we can actually demonstrate. So huge credit goes to Kirti and Sai for the awesome work they did in architecting and getting it to this stage, along with Sudarshan and Indu. So yeah, thanks a lot, team. So coming to the agenda, right? So we'll be starting with what was our vision, what was the pain points, and what are the open source credits that we are using. And we'll then go through a series of demos and walkthroughs. So the demos and walkthroughs will be in a sequence, like we'll tell what is the challenge, then we will show or demonstrate how Drona helps in overcoming that challenge. Then finally, we have the future scope that is still in progress. So this is still an early preview. So we have the core functionality more or less done, but there are a lot more things that could be added as well. And at any time, if you guys have any questions, feel free to ask in the chat, and Kirti and Sai will help in answering them. So the vision that we started with was we wanted to create an open source LabVIEW UI testing framework to automate manual testing, which would result in an overall software quality increase and reduce the manual time required by the engineers for testing. So we know that there are already multiple unit testing frameworks available, but for UI testing, as far as we know, we were not able to find any easy to use open source framework available that is for specifically that will support LabVIEW. And that is something that we wanted to at least take a stab of getting it rolling. So the existing pain points, yeah, like everybody knows, with UI testing, there is manual time required by the engineers. And as far as I know, there was no open source LabVIEW GUI testing framework available. And there are other open source frameworks based on mouse movements and taking snapshots and comparison. But yeah, those things will not work always, because even if there's a slight change in the font or color, there could be something that could go wrong. So we wanted to make it a bit more robust than that. So that is where Drona came in. So the tech stack is, we are using LabVIEW 2016 32-bit as the source code. So that means that Drona can be used for any LabVIEW project that is 2016 or greater. It can also be used in 64-bit versions of LabVIEW as well. And Drona is an open source project, and that is available in the GitHub public repository, and that is the repository URL. And yeah, Drona was not something that was not completely built from scratch. We leveraged some of the existing open source tools, and full credit goes to Karaya for, we leveraged Karaya for the assertion and test framework internally. So only we wanted to deal with the UI portion of it and leverage Karaya for the assertion and other APIs that already it supports well. And the other is we also used SLL toolkit, that is also one of the internal open source tools for some of the utility VIs. and we also used OpenG toolkit, and we also used some of the examples from NI forum, which is also comes under the MIT license. So next is we want to do it in open source, right? But then the question comes up as what open source license to use, right? So I'll just take a quick minute to talk about there are two primary categories of open source licenses. One is called copyleft license and another is the permissive open source license. Copyleft licenses are something like GPL, and the primary the constraint or the requirement is that any code that you are building on top of copyleft license or you are statically linking to a copyleft license should also be disclosed as source code. But this may not be something possible for all commercial and other customer oriented projects. So the other section is permissive open source license, which are supported by both any proprietary application can also freely use it. So some examples of permissive open source license are MIT, BSD, Apache. So yeah, of course, I am not a lawyer. Please don't take this as legal advice. This is my interpretation of open source licenses, and I think mostly it's this is how it is. So for Drona, we went with the MIT open source license, which means that you can be used in commercial use. You can freely distribute it. You can modify it. You can use it privately. And the only condition is the license and copyright notice should be retained. And the limitations is there is no liability or warranty claim that is possible. So that is what we have gone with for Drona. Okay. So then next is coming to the Drona workflow, right? So typically the flow is for any testing, you set it up, you give some stimulus and you assert it. And below is the Drona palette that provides the different APIs to perform these operations. So without further ado, let's just straight away jump into a demo. So here I have a very simple calculator, which has two numeric inputs, one numeric output, and I have different buttons for different functionalities. And let's say if I want to test, let's say the add functionality, right? The flow will be something like I want to set some value to input 1 and I want to set some value for input 2. And then I need to click on the add button. And after clicking the add button, I need to verify what is the value that is present in the output indicator. So this is how the flow will be. So now let's just dive in and see how we can create this test flow using Drona. Okay, so this is my LabVIEW demo project. So this is a simple calculator. So before running it, I'll just simply run it manually. So let's say I'm just adding 12 and 3 and result is 15. So now I can just go ahead and stop this. So first is what Drona requires is it requires an INI file that needs to be placed in the root directory. So that is this INI file. And what this essentially contains is for this project, we need to tell what is the starter VA present. So, and this can be a relative path. So here I just have launcher VA as main.va because this main.va is present just parallel. So I can just give the name alone. So the starter VA path needs to be provided. And I have a couple of flags which says whether I want to run this VA and whether I want to open this VA. So this is the first requirement. We need to have this INI file set up in the root directory. And all the tests in source code from Drona has to be executed only from LabVIEW project. So that when we use the application directory path, it will point to the project directory root. So if you are opening from directly from any specific VI, then the application directory path will not be correct. So in that case, it will not work. So one limitation or constraint is the test has to be executed only from this project instance, so that the root directory is proper, and the root directory needs to have this drona.ini file. Now let's go ahead and I'll go ahead and create a VI here, test VI. So let's say test. Similar to Karaya, we can just create a VI for testing. So I'll just call this as test add. And so Drona palette will be available under add-ons, SLL Drona. So this is the Drona palette. So first API we need to drop is the setup. And since we are leveraging Karaya, right, we need to tell this is a test case. So how we do that is we go to the Karaya palette and we call the define test, which just takes in a single input called what is the test name. Here I will just say that this is a test add. Even this is optional. If you don't pass any input, it will automatically take the VA name. So I just tell this is a test add and I'm calling the Drona setup. And this API, what it returns is it returns me an application reference and a VA reference. Application reference will be the whole application reference, and then the VA reference will be the launcher VA's reference. So now once I get the VA reference, now what I next need to do is I need to apply a stimulus for input 1. So by this time, since we already set up the flag to run it and open it, so we don't need to take care of, so already by this time, the VA is already running. So now we can get started with applying the stimulus. So we have this polymorphic VA for applying the stimulus. So so here what I want to do is I want to apply something to a control. So I can just say control set value auto selection, and I can just pass in the VA reference to the stimulus VI, and I need to tell what is the control name or path. So that is input 1. So this is my input 1, and this takes in a variant because you can apply any value to any control. So it does not, we don't have any specific way for each data type. So this is a variant. You can just wire in the appropriate data type. As long as the data type is proper, it will work, or else it'll throw an error. So here I want a double constant, and let's say I want to pass 13. Okay, so now I have triggered the input 1. Similarly, I want to set up the input 2 as well. And for that, I can just change this to input 2, and I can say that this is 2.4. So now I need to press on the add button. So that is again a stimulus of a control. So I can just still go with set value auto, and I can just pass in the VA reference, and I need to tell the label. So this will be the label of the control. So here in my case, the Boolean text and the label is same. So that I know, and I need to use the label. And the label, of course, has to be unique for this whole thing to work. So I can press add, and I'm passing a true value here. And now, yeah, our stimulus portion is done. Now we want to check the output. So that is assert. So we just drop the assert API. And similarly, I need to tell what is the indicator name. So that is output. And the value that I am expecting is 15.4. And similar to Karaya, we have a lot of comparison options. In control value, we have like e greater than equal, almost equal. So almost equal will be helpful because in double there is small errors that might happen because of the way in which they are stored. So we can go with almost equal here, and I can say that this is okay. Yeah, that's it. So the flow that I showed, right? That is how we can easily recreate in Drona, and of course we can close the references, the application reference and the VA reference. So I am then taking the application reference and I'm closing it. So this is just a very simple flow. You just drop the setup and then you just straight away go into triggering all the stimulus and then checking what is the value that you want to check. And this VA doesn't need to be open or running. So the only thing is the test VA should be part of the project instance. It should be open in the project, and we can now let's go ahead and run this. Yeah, it's all done. So it opened the VA, it ran it, it set the stimulus for input 113, input to 2.4, and then it clicked the add button, and then it verified the output as 15.4. And yeah, we have the nice Karaya unit testing report place where it said that this has passed successfully. So this is a very simple example, and it's as simple as this to get started with Drona. So we wanted the user experience and developer experience to be very easy to use. So that is one of the primary philosophies that we have. So yeah, we still have few more use cases and challenges to cover. So for that, next I invite Kirti to present about the challenges. Over to you, Kirti.
Sure, Karthik. I'm sharing my screen. Let me know if you can see
Sure.
my screen.
Yeah.
Is my voice clear, Karthik?
Yes, Kirti, your voice is clear. Yep.
Sure. So next challenge in UI testing is there is some randomness involved in the output, right? So we will not know. Okay, after providing all the stimulus, we will not know when the output will be available in the UI. We might be dealing with some time-consuming process, right? So there will be some randomness in it. So what Drona is doing is like it will provide an API. That API will be polling for the expected output in the UI, and it will wait for a given amount of time, and after that it will fail the case. So we are providing this API to test this kind of randomness, right? Yeah, I will quickly show a demo on this one. Okay, Yeah. So here I have a simple timer. So I will quickly run it. So we can start the timer and we can pause it and resume it. We can reset or we can stop. So stopping will stop the entire timer. VA, right? So in this case, okay, I'm trying to do following test case flow. So I want to start the timer and I want to wait for 3 seconds, which means I want to wait until this indicator shows 3 seconds, and I want to pause it, and I want to really check whether it really took 3 seconds to do that. That is my first test case. And the second test case is like I want to pause this at the 3 second, and I want to wait for 1 second, and I want to resume it back and wait for 3 more seconds to see whether it shows 6 in the stopwatch. Okay, this will be my test case. I will quickly show how this happens in the Drona. So, like Karthik mentioned, we want to define Karaya test first, and yeah, here we are waiting. Okay, we are starting the main VI, and we are waiting for it to settle. And this is the first test case, right? So here we are going to simulate start click, and we are going to wait until the indicator shows 3 as a seconds, current second, right? And after that we will be checking the time difference between them, and we will be asserting whether it's really a 3 seconds. Okay, this is the first test case. And the second test case that we are going to do is, okay, we are going to pause the timer. We are going to wait for 1 second, and we are going to resume it back. And same thing, we are going to wait until the indicator shows 6 seconds, and we are going to assert that difference between the events. Right? I will quickly run this. Okay, finally, we will just stop the V. I will quickly run it. Yeah, we can see like that test is waiting until that particular indicator updates the record expected value, right? Okay. Yeah. So this is one of the challenge, and the next challenge that we faced is okay. In the real world application, usually we will have subpanels to show dynamic content in the UI, right? So we also thought of providing a support for subpanel. And yeah, in LabVIEW, we can reach a controls present in the subpanel, but it will not be that easy to reach that particular control present in the subpanel, right? So Drona, it provides an API. Yeah, like Karthik mentioned, we want to give a control name or control path, right? So here we can give a control path to reach the controls present inside the sub VA. I will show how. So let's assume like we have a top level VA, and the top level VA has a subpanel, and we loaded a VA inside that subpanel, and that particular VA has a boolean named boolean1. So if you want to simulate something to this boolean1, this is how we want to give a control path. Starting from the top level VA, we have a subpanel with the label subpanel. That's our first input, and followed that we are expecting a VA with the following name, boolean control, which is present inside subpanel library, right? And inside that VA, we are expecting a control with the label boolean1. So this is how we can provide a path to the controls inside subpanel. Okay. Yeah. So next challenge. Okay. In short time, I will demonstrate all these things. So next challenge we faced is like how to support a latch boolean. So in LabVIEW, we cannot value signal a latch boolean, right? It will throw an error. So how we address this problem is we used keyboard. First, we will just set a focus on that boolean, and we will simulate a spacebar click from the keyboard. So that will in turn click that button. So that is how we are addressing this latch boolean challenge. And yeah, in okay, developer can switch between value signaling or keyboard inputs manually, and Drona is also providing an option to let it choose automatically. If you say auto to Drona, right, it will choose between value signaling or keyboard press based on the control we are targeting. Yeah, and next challenge that we faced is like we try to test a numeric control with a min and max limit set to it. But when we try to do a value signal to that numeric control, even though the signaled value is outside of the limit, it's still accepting it as a valid input. So again, we used keyboard simulation to address the problem. So we have we provided a keyboard API that will take raw keyboard inputs and it will just run it in sequence. Okay. And yeah, in future we are also planning to write a wrappers which will address specific need for developer for testing. Yeah, that is in our pipeline. Okay, I will demonstrate all these challenges. Okay. Okay, so here I have a VA similar to I shared in the PPT. So if you run this VA, so here we have a drop down. This drop down will decide what VA to be loaded in the subpanel. So first thing is a latch Boolean simulation, right? So here it's very simple. So if you click a Boolean one, the string indicator will get updated with this text, and if you click a Boolean two, it will get updated with the following text. And I will quickly switch to the numeric control. Okay, here this particular numeric control has a limit between okay, lower limit to be 100 and higher limit to be 200. Yeah, so if I go lower or higher, it will get it will get coerced. Okay, this is the VA I have, and I will show the test cases that we written for this particular yeah, we want to do all the usual setups, and followed that we are just simulating the drop down selection. And here I'm asking it to select latch Boolean simulation, and after that I'm just calling a sub VA to simulate all other test cases in that particular VA. So here if you see, I'm providing that path, right? Like in the top level VA, how this particular subpanel can be addressed. So that can be addressed by naming subpanel and providing the VA loaded in that subpanel, VA name of the, yeah. And if I go inside the sub VA, here, yeah, like I showed in that VA, right? First thing that we are going to do is we are going to simulate a latch Boolean click here, right? I'm clicking a Boolean one, and I'm just asserting whether that string indicator is showing the expected value. And the same thing happens for Boolean 2, right? And moving to next test case. So again, I'm going to simulate drop-down selection. At this time, it will load numeric control coercion, and similar to that, I'm going to provide a path to it. And inside this subpanel, sorry, inside the sub VA, yeah, these are the test cases I'm going to try. So first, I'm going to type in 50 through keyboard, and I'm going to assert and check if it's going to okay, if it's got coerced to the lower limit 100. And second test case would be like typing 150 and checking if same thing is reflected because it's within range. And finally 300, which is outside of limit, and check if it's goes to 200. Okay, this is the test cases we have, and this is the API I talked about, keyboard simulation API. Okay, I will quickly run this. Yeah, yeah, these are the challenges we faced, and this is how we addressed. For the next demo, I will point to Sairam. Yeah.
Thank you, Kirti. Yeah. Hope my screen is visible. Yeah.
Yes,
Okay.
it's visible. Yeah.
Okay. Thank you. So, as we all know, so we used to write. There will be a lot of similar functionalities that will happen in a UI. So uh, in case of that, right, so what Drona helps us is, since we have the power of programming, we don't need to write the test case again and again. We can just loop it over with the help of LabVIEW and use that as like a easy regression test. For example, let's consider an example of car wash, which is a sample LabVIEW CLD question. So in this, what we have is we have a lot of wash options. So we can select different wash options, and start it and move the car position slider to the required position. And then when you run this, you'll see the different wash happening and the timer glowing, right? So I would just like to show an example of how this can be done using Drona. So let's say this is our solution, which is the car wash. So some sample tests are like, so I select this underbody wash, click on start, and then move my car position to underbody wash. So then this gets executed and then you finish it out, right? So this is one thing. Similarly, I can do a bug remover. I can do a start. I can move it to that position, and I have this. So in this case, there are 8 different ways of test, 8 different tests that you can do, or I can choose combinations of different things and then doing it, right? So this is like one place where Drona helps with the help of programming using loops, right? So I'll just open the sample test cases. So let's say I have like what we already saw, right? So we have a place where we set up the VIs, and then I'm just getting a config which I want to loop over, and then I just do some init tests. So one additional assertion that can happen here is like we also have this control enabled, disabled, and grayed out, right? So you can also check for control disabled or control enabled upon certain uh, stimulus. So initially we are going to check if everything is enabled and it's all in place. And then the main thing that comes up here is this regression, where I can just create one common test and just loop it over to test all the different cases. So for example, this wash array actually contains a set of different items and the corresponding timings associated with it. So with just looping it over this array, I can able to test all the different options that are available, right? So here let's get into this wash test. So here it opens the front panel, and here you can see this control path. So like as Kirti already mentioned, like for subpanel we use this subpanel double arrow, and then we use this. Similarly, cluster path controls inside a cluster can also be referred through using that path. So this underbody wash can be called by wash options double greater than underbody wash. So the path of the individual items in a cluster can also be defined. So here I'm going to just value signal this, and then I'm going to set the start. Okay, so you can either use, if you directly know what is value signaling and what you have to do key focus, you can do, or set it to set value auto, it will do it automatically. Yeah, and I'm just checking the different disabled items, different grayed out items, and then I'm setting the value, and I'm waiting for the wash indicator value. I'm just capturing like what we did in the timer example that Kirti mentioned. So we're just looking into the thing and waiting for a timeout value, and then we are checking the actual timeout. So similarly, I can write some more test cases to do multiple select operations as well. So multi-select, I can also loop over things, right? So which is now easier, right? So now you have a code, you can just loop over the different things that you have handled, and then I can run the test process for each and every individual selection, right? So now let me just run this and show how this works. Just added some delays to showcase the different things. So I'm just running this. So as Karthik mentioned, I'm just running it from the project instance. So I have the solution here, and I'm just running this car wash test case. So this just opens it and it starts running it and tests it across different different cases. So every individual wash option is tested, and then finally, once you test all the individual options, all the 8 things are selected together and tested. So in this way, I can just do one code and loop it over for different scenarios and test cases for things that are related to each other. Yeah, so just 2 more minutes and to show how the whole thing is also running. Yeah, so this is done. So now again, I can select everything, and then it does an automated testing here. Yeah. So you can see the results getting loaded in the Karaya's inbuilt UI test results UI. Yeah, back to you, Karthik.
Thanks a lot, Sai. Nice demo. So let me go ahead and share my screen. Sai, is my screen visible?
Yes, Karthik.
Okay, sure. Yeah, the one other challenge or one other scenario we usually encounter is we don't always have all our code in one single frame. Sometimes we do have pop-ups, and sometimes these pop-ups are custom LabVIEW pop-ups as well. So we want to also interact with these pop-ups, and we also want to trigger closing of this so that we can get back to the frame and do. So Drona also abstracts these challenges internally and provides an API which user can directly use. How it does is basically, let's say in the simple calculator, let's say when user presses the square button, a pop-up comes. So what all we need to do is, we know that once the square button is clicked, the pop-up will automatically come. The only thing that we need to do next is we should be able to somehow catch hold of the reference of the pop-up. So for that, Drona provides an API where we can specify a VI name, and it will be able to get the reference of that VI. And it automatically has a timeout, which means that it doesn't mean that once the square button is pressed, immediately it will expect that VI reference or that to be active or loaded. So it will wait till 5 seconds and it will keep retrying till the VI gets loaded. So this is one other option. So now once we get the VI reference, right, it's as usual. So once with the VI reference, we'll be able to then trigger any inputs within this pop-up, and we'll be able to interact with all the buttons here. So all those things is like as usual. The only thing is we just wanted to catch hold of the VA reference, and that is made possible using this Drona API. So this is one challenge. The next is, what about the LabVIEW built-in pop-ups, that single button and two button dialog box. So similarly, it has a dynamic nature. We won't really know the pop-up when it will actually come up, but and as far as I know, I think there is not an easy way to get a VA control reference to the pop-up. I don't even know whether there is an actual VA or not. I think it's possibly not. So the workaround here we thought of is that let's say without mouse, even when the GUI, right, it's possible to interact with these LabVIEW built-in pop-ups just by using keyboard. It'll automatically usually have the OK button automatically selected. So if you just press return key, it'll automatically take the OK button, or you can use tab or escape to close the pop-up. So Drona provides, like we already saw, Drona provides a keyboard input API using which we can interact with these LabVIEW pop-ups. Of course, we won't really, there is no current mechanism to know when the pop-up is actually encountered. So as a workaround now, what we are suggesting is go with a hard-coded delay of sufficient time to make sure that if you know a pop-up is going to come, you add the delay and then you trigger the keyboard input. So it's as simple as this. Like for example, in the again the simple calculator, I have a pop-up when user presses the square root, and now I have a two button dialog which is having OK and close. So now what I do in the Drona API is I just use the direct keyboard core API and just say I want to press the return key after waiting for 1 second. So which means that the pop-up will come and the return key will be taken by the pop-up, and it will again go back and you can continue with your usual flow. So this is these two are supported. Yeah, before getting into the EXE support, maybe I'll show you a quick demo of these two. So I have again the simple calculator VI, and yeah, so I have tests. So I have the test as a library and I have all the tests within it. So test add is something that we already saw. And for test, the square is the pop-up one. So if you see here, yeah, we have the setup API similarly. And I click the square button, and the only changes between the other one and this one is just insertion of this new one. Instead of using the frame VA to trigger the bunch of stuff, we are getting the VA of the pop-up, VA reference of the pop-up, and then with that we are interacting with it. And then finally we are triggering OK button in the pop-up to close it, and then we are closing the main frame as well. So this test case can be independently executed as well. So let me go ahead and run this. Yep. So it's done. So basically I had two cases, like 10 square is 100, and then I'm resetting it back to the default value. So both these got executed. So this is one way of doing it. And the next is the square root. I can even leave it open. I think that will work, I think. Yep. So for square root, that is a very basic test case. I just did it for demonstration. Basically, I know that the pop-up will come, so I'm just pressing the return key after 1 second and closing it. So now So we have a bunch of these tests, right? Do I have to manually go and run these tests? Not really. So Karaya provides a way to just run all the active tests in the project. So if you go to tools, Karaya, run active tests in the project, it'll automatically identify the tests within the project and it will run them one by one. So I can sequentially run these. So let me go ahead and click that. Yep, it's done. So yeah. And one thing to notice is that since we are using a combination of values, I mean, if you're using just control reference, it doesn't matter. Even if the VI is hidden or if even if some other window is open, that is fine. But since we are using a combination of keyboard press, we need to make sure that during testing, we should not interact with the application to make sure that the proper topmost pop-up or VI is in front when the keyboard press is actually happening. So that is one thing to note. So yeah, and other thing I want to probably also touch base upon is that so we have a Drona API that is part of each test, but we are not really closing that window. So what actually happens is Drona internally checks whether the VA is already running. If it's running, it will automatically catch hold of the reference and returns it. Or if it is not already running, it will make it run and then return it. So that abstraction is also handled internally. So you don't need to really worry about whether it's already open or not. You just simply drop Drona API and you can straight away get the control reference and start coding your tests. So that is on that. So next, coming back to the slide, right? The next major challenge is the EXE support. So this is something that we tried multiple things, and one prototype Yakiti and Sai did, and we were able to get initial version working just this weekend. So the only thing we thought was it should be pretty straightforward, right? We have an application reference and VA reference. So all we have to do is instead of getting the current LabVIEW application reference, we are able to get the reference of the EXE, then we are all good, right? That's what we thought, but unfortunately that was not the case. Like for example, there were some unknown issues. Like for example, if it is in an EXE, right, getting a reference of a VA loaded into a subpanel that was not working. So if we get a reference of the VA loaded into subpanel in source code, it was working. But if in EXE, inside EXE, if you have a subpanel and we are trying to get the VA reference that is loaded into the subpanel, that was not working. We are not able to catch hold of the reference within the subpanel in EXE mode. So as a workaround, what we did was we converted the Drona test VIs into a pack project library, and we loaded the pack project library into the EXE and we ran it. So this prototype, we just did a very basic prototype this weekend and it seems to be working. So the idea is we are making the test to be run within the application instance memory itself without actually building the test VIs into the EXE. Your EXE can still be as older one. You don't need to statically add the test VIs internally into the EXE, but what we are doing is we are dynamically loading the PPL VIs in the EXE's memory instance and then triggering the running of it. So let me go ahead and show you how that is done. So for the simple calculator, yeah, I have this and already I have created a library for it. So now for this, I have two build specifications. I have an EXE and a PPL. So the EXE basically builds the application into an EXE, and then this test library gets converted into a PPL. And one thing to notice to make sure that we are able to load a VI into the EXE memory, we need to do some configurations for the INI file. So that is already done, which means that we have to enable the port access. We have to allow the VA access. So there are a bunch of configurations that needs to be done. And that can be done using this INI file. So I basically have a static INI file, which I want to use while building the EXE. If you just do a normal build EXE, it will not have this configuration. So you'll not be able to load the PPL into the EXE memory. But with this configuration, it will allow the VAs to be loaded into the memory. Maybe this can be even temporarily used when actually testing and not for actual deployment. So it can be just used for internal purposes as well. But yeah. So now coming back. So I have a, okay, 1 minute. Explore. So I have a builds folder. Inside that I have the exe, which also includes the drona.ini file, and I have a test folder which includes the PPL. So we saw that for source code, we need to mention what is the launcher path, right? But for exe, we need to mention the name instance, actual namespace for the frame VI. So here I'm providing the full namespace, which includes the library. So simple calculator LBLib main. So this will be the launcher name that will be used in exe mode. And so let's go ahead and run it. So Drona provides an API to run a test in EXE. It also provides an API. The API basically takes in 2 inputs, and that is basically we need to specify the EXE location, and then we need to mention the PPL location. So this is just, I just have this VA just as a handy one because I want these to be hardcore specified as default so that I don't want to manually go and choose every time. But yeah, Drona basically provides this API which provides a way to specify the EXE path and the PPL path. So now we just simply have to run this. So Drona will take care of launching the EXE, and it will take care of running the tests one by one in the EXE mode. Yes. So yeah, I'll probably touch base upon how this actually works. So if you see in the, let me go back to the project. So in the PPL, we have, in addition to the normal tests, user needs to create one more VA called run.va. And all they have to do is they just have to drop one core API from Drona. So in EXE mode, what we are really doing is we are just simply running this run.va. When no inputs will be passed to this VA. We are just loading this VI in the exe memory and running this. And what this run core does internally is it actually finds a list of tests within the PPL. And how it finds, it basically checks the list of VAs which starts with test. So it assumes that all the tests will be starting with test. It catch holds of all those test VIs and runs them one by one. So that is what this Drona API will do. And this run API has to be present in this PPL because we want to have this run to be exported or to be available when from the PPL. So PPL by default will only have the APIs that is present directly under the library. That is why we have this run API. So with this, we have the initial EXE support, which includes pop-ups, both LabVIEW and custom pop-ups. All those things are there, and initial things looks promising. And any questions, feel free to ask in the chat. So coming back to the slide deck. So for EXE support, we just basically have to tell the EXE path and PPL path, and the Drona will take care of launching the EXE and run it. So one more thing to notice is that if you remember, we placed the Drona setup, right? So that internally handles EXE mode and source code mode internally. So all the changes, user doesn't need to worry about whether it's an EXE or normal mode. They just have to simply get the VA reference, control reference, and do their code. Drona takes care of handling EXE and source code internally. So out of, so future scope, still there are a lot of things that could be added upon. So like out of box, we don't have any APIs or something for list box, table, tree. Basically, those things are not currently available out of box from Drona. And support for clones, this is one other major thing. I think currently we are not supporting clone. We have to think and see how we can support clones and make it a bit more easy to use, like especially when there is a clone that is getting popped up, right? How do we actually get the clone via reference? If it is just a pop-up with just a single instance, we can just use the name and get it. But if it's a clone, then that is something that we need to tackle. And similarly, there will be some cases where we want to do mouse support. And sometimes when user clicks a button, there will be a file dialog box coming up. So that is something we need to check. And menu is also something that we have to see. Probably, I think menu probably can have keyboard shortcuts attached to each of the menu items so that it can be easily invoked. But these are some of the future scope items. And coming back, this is the Drona palette. So one more thing to especially want to mention is that even though I've told that we are not currently supporting list box or tree, right? Drona's APIs are pretty scalable and open. So there is actually a way to, you can just tell the control name, you can get the control reference. So that API Drona provides. So even if some testing or assertion is not currently supported by Drona directly, you can write your own code to make that any custom functionality possible. So any custom testing or functionality can be done using Drona by just catching hold of the control reference. Instead of letting Drona do the stimulus and assertion, you can even do those for things that are not supported by default. And as stated earlier, Drona is an open source project under MIT license. Source code is available in GitHub, and everybody is invited to contribute, add, and improve features to Drona. And like I told, this is still an early phase. This is just an early preview. So currently the palettes APIs could probably change. So we have a forms where people who are interested to either try it out, give feedback or contribute, please fill it out and we will reach out to you. So currently we have a package, but I think, yeah, we wanted to make sure that at least we want to make sure that the API documentations are proper and they are having a proper connector pane without changing, so that people may, after starting using, we don't want them to break their stuff, right? So that is why we have not yet hesitant to publish it directly. But yeah, that is the only reason. Once it gets to a stable state, the releases will be available directly in GitHub. So coming to the final thing, what is our big, hairy, audacious goal? So we wanted Drona to be like something that people can straight away use for their LabVIEW UI testing, so that it makes the overall efficiency of the engineer more, and also makes them happy, right? You ship better software, you automatically be more confident and happy. So that is our big, hairy, audacious goal. And yeah, similar to VAPM for LabVIEW packages, we thought Drona could be the one for LabVIEW UI testing framework.